Disseminate, the computer science research podcast, the DuckDB in Research series.
Hello and welcome to another episode in our ongoing collaboration with DuckDB. So we've got another episode of the DuckDB in Research series today, and I'm really pleased to say that today I'm joined by Mihail Stoian. Mihail is a PhD student at the Data Systems Lab at the University of Technology Nuremberg, where he is advised by Andreas Kipf. And his research is on robust query processing, and that's what we're going to be chatting about today. He has published a paper titled Parachute Single Pass Bidirectional Information Passing. So welcome to the show, Mihail.
Thanks, Jack. Nice to be here.
Fantastic. So we always start off by getting you to tell the listeners a little bit more about your journey and your story and how you got interested in query processing and database internals. So yeah, what's the story there?
Yeah, it's a cool story. So I'm from Romania, so I started there to do informatics from the 9th grade, and then I came to TU Munich, right in Germany. And to be honest, before I was not so impressed about SQL and stuff. Like I remember it was like in the last year of the high school, and I told my teacher, why SQL? With the C++, we can do much of the things. And then this change when I came to TUM. There was Professor Alphonse Kemper. He had very nice classes, and he was telling about research and hyper, and I was impressed about that. I just went in the lecture break to his desk, and I also do I also want to do research, and he was like, okay, I do know C++, and I told him yes, and then I wrote him on an email, and that's how it started. And then during the studies, I worked with Professor Neumann, and of course, he's the expert of query optimization. So I was it was very fascinating to work with him. So that's the complete story, so to say.
Nice, yeah. I mean, that's a good tutelage to have under Thomas Neumann, right? So yeah, that must have been a really great experience, and I imagine you learned a hell of a lot to work with him closely. Cool then. So let's talk about the topic at hand today then. And Parachute, single pass bidirectional information passing. There's some terminology there that the listener might not be necessarily familiar with. So let's give them some context. Maybe we can start from kind of the very top, what is pipelined execution in query processing, and sort of where do these terms like sideways information passing, what do they mean in that context? So yeah, give us the context, Mihail.
Yeah, so sideways information passing is rather a generic term. In principle, you want to send some information before you execute the actual jobs. So, for instance, you want to have really fast joins. This information is most of the time a representation of the key space, and namely after a filter has been applied to the base table. So, for instance, what people use, they push Bloom filters to represent this information, and this information is mostly like the key space. What modern database engines do, like Redshift, they implement a lightweight sideways information passing. So let's say you have two tables from TPCH, line item and orders, and if there is a filter on orders, like order data greater than January 2020, you build a Bloom filter on the order key, and then you push this Bloom filter to the table line item, right? And this will pre-filter the table before you do the job. That's what we refer to like a prop site filtering, right? You filter the prop site before you join. Is that clear?
Sure. So, what are the limitations of these current or the current approaches that you just mentioned there, like systems like Reddit? What are the limitations with this, and why do you need better solutions? Like, why is prop site filtering not the necessarily the best, and how do maybe some of these like instance optimal algorithms, like Yana can't pronounce it.
Yeah.
It's a hard one to say. How are they better?
Yes.
But then why don't they work in practice as well, right? So
Yes.
yeah, tell us a little bit more about that.
Yes, that's a very good question. So the main limitation of the implementation of sideways information passing, right? This prop site filtering is that if you push the Bloom filter to the prop site, the information will go from the bottom of the plan to the top of the plan. So that's a unidirectional flow of the information. What these instance optimal algorithms do, they also have the backward information flow. And that's the a key difference between what Redshift does, what Snowflake maybe, right? They only have like an unidirectional flow, and it's also a bit hard to implement like all these instance optimal algorithms like Altan from Ethereum has now like this lookup and expand. And that's a bit more practical, right? But to have like this prop site filtering, that's actually fast, right? And it's working well. Like that's.
Okay, cool. So that's a nice segue onto Parachute then. So give us the high level sales pitch on Parachute then. So what's the TLDR?
Yeah, so Parachute takes semi-join filtering to the next level. So semi-join filtering, as we discussed, only induces a unidirectional flow in the plan. And by maintaining like very lightweight join induced fingerprints, and they are called like parachute columns, right? A parachute enables the missing direction of the flow, which is done by these instance optimal algorithms. So you can see Parachute as an interpolation between prop site filtering and the instance optimal algorithms.
Nice, cool. So can we maybe like walk through in a little bit more depth then kind of how Parachute actually works? There's a few things you mentioned in there, like the fingerprints and these Parachute columns. So maybe you can run us through with an example might help us here as well, Mel, to sort of visualize kind of what's going on.
So Parachute, like the workflow can be divided in 3 simple steps. Let's start with these fingerprints, the Parachute columns. You can also see them as cached Bloom filters. Let's say you have like a workload in which a table orders has many filters on the date, right? Like by the year. And that's typical for BI dashboard queries where you want to zoom in some ranges. Now, if you apply a semi-join filtering at runtime, you would build Bloom filters at each single query. Mm-hmm. And you would push them to the table of line items. And now that's pretty expensive. What you actually want to do is to cache these Bloom filters in such a way that you can reuse them, right? So, for instance, you can build like a histogram on the order date, like for the years, right? And that's actually what a Parachute column is. It's like a fixed bit width column, which represents concisely a column. For strings, that's a bit much more difficult, but we also found a solution for that. So that's what the parachute columns story is about. Now at query time, a parachute does a rather clever thing. It looks at the query plan and sees between which table pairs the information flow is blocked. Let's say the plan has a primary key table at the end of the plan, right? So the information from this table in the normal probe-side filtering is not coming to the bottom of the plan. A parachute sees that, right? And then it converts the predicate on the primary key table to a parachute predicate on the foreign key table. This way, from probe-side filtering, you have the the flow upwards, and by this transformation of the predicate on this primary key table, you also have the downwards flow, and that's where the bidirectional flow comes from. So that's the second step, and of course you also have like to translate these predicates, right? And that's based on these histograms. So, for instance, if you have like a simple filter like a year greater than 2024, right? You locate this year in the histogram, and let's say it's a bucket 3. Then the parachute predicate will be like parachute of year greater or equal than 3. And it's possible also to do for strings. That's actually very interesting. Yeah. But that's mainly the these parachute columns, the analysis of the plan, which table pairs are blocked, and of course to translate these predicates to enable the flow.
Amazing. Yeah, we can maybe touch on the on how you catered for strings in a second. Yeah. That sounds very interesting. So maybe we can take that now. Tell us about how you did that now, actually, because I want to get on to how you took these ideas and this design and implemented them into DuckDB, obviously. But while we're talking about the theory and the overall approach, talk to us about strings as well.
Yes. So strings is probably my favorite thing in Parachute. Like these zone maps, right? The min and max ranges, right? To prune data. If you think like a very, very, like there is no string zone map in Parquet, right? Mm. What Snowflake does is like a prefix zone map, and that's all. Mm. But you don't have zone maps for like predicates. Let's say you do like Jack, right? And there is no way to filter Parquet files based on that. So the main idea is to cluster the letters. So say like Jack, G, and they go to bucket 1 and okay, to bucket 3. Then you build a bit mask bucket 1, bucket 3. So it's like 0, 1, 0, 1, right? And then all the strings which have these buckets will possibly be matches, right? So for Parquet file pruning, all the files that don't have a superset of your bit mask will not qualify.
Yeah, that's I can see why that's your favorite part of the paper for sure. Cool. So let's talk about how you put these ideas into practice then, and how what it was like to implement this in DuckDB. So yeah, tell us about the integration overall and what specific modifications were required in DuckDB to realize Parachute.
Yeah. So Parachute now, right, is mainly a Python framework. What we did, like, and let's the contribution of Andy Zimmerer, he implemented like this probe side filtering in DuckDB. And that's probably what you are looking for, right? So for Andy, like this was pretty easy since he did like 3 years at Snowflake, right? So he was like very experienced.
Yeah.
And DuckDB already had some sort of sideways information passing. There is this min and max push down, and also some in filter trick to push the key space from the primary key from the build side to the drop side. And he did that in 1 week, I think. Like he was really fast. Yeah.
Oh,
And
great. Yeah.
there was a lot of debugging since Bloom filters, they are a bit problematic. So yeah, that's mainly the modification in DuckDB. That's now open source, so you can use that. It's also faster than DuckDB, and Parachute improves that much more. Right? That's the whole idea, to improve also on this probe side filtering.
Yeah, that's really cool. I guess that's probably a nice segue as well. Then so before we do the evaluation results and whatnot, and see what the actual performance improvements are in DuckDB, how long did it take end to end to sort of for the DuckDB integration? What was it? Long time, or I mean, the part of it took a week, but how was the overall development timeline?
Yes, I think it took almost 1 month.
Okay.
To have like the probe side filtering without bugs, and also with parallelization. My framework was important, so I didn't have to implement in DuckDB. I used from DuckDB this nice extension for UDFs. That's pretty cool. And I think I also used, I think that was the mainly one. Right, so yeah, this was for me pretty cool, to have Python UDFs in DuckDB. That's pretty cool for me.
That's definitely a really nice feature. Cool. Then, so let's talk about how Parachute performed then against sort of vanilla DuckDB with the pro tab filtering, and then the extra bits on top to make Parachute work. So let's start off with the experimental setup, and what did that look like initially, and what were the benchmarks you were using in the data sets and things like this, before we then can talk about how much faster it was? Yeah.
Yes. So when you evaluate the Parachute, you should be careful, right? Since it builds these Parachute columns. So that's a main idea to also account for these Parachute columns, since they take some space on the file. The benchmarks we use is this standard GOB benchmark. That's mainly for query optimization, right? And there is also the CB benchmark. That's an extension of GOB with 13K queries, right? So it's like a huge benchmark.
Mm-hmm.
And of course, for the setup, you have to measure the speed up, of course, but also the disk space, right? The file size. Since if you build these Parachute columns, they will be built on the tables, right? So you expect with larger bit widths of the Parachute columns, you have faster queries, right? So that's one thing to account for. So for instance, with 16-bit Parachute columns, you get a speed up over vanilla DuckDB of 1.54 on the GOB benchmark. And if you want to speed up the probe side filtering, so this what Andy optimized for, that's 1.24x, right? So it's faster than also probe side filtering. And why? Because you activate the downwards flow, which comes from this instance optimal algorithms. So that's the key idea. And of course, if you build these parachute columns, right, that's also an overhead, right? And we measure that the build time for these parachute columns amortizes after running 4 times the GOB benchmark, and for CB, like for this 13K queries, that's amortized in the first run. And so parachute is like built for this huge workloads with filters that change, right, the values, like the year in the date. So yeah, it's
nice. Yeah, sorry, continue.
Yeah, like that's
really cool. So it's for those, because my next question that I was going to ask is, are there any sort of like limitations or like specific corners or types of workloads in which Parachute maybe kind of it's maybe suboptimal? And I guess it would be maybe it's not necessarily suboptimal on workloads like the job benchmark, but like it's better at sort of things like CEB, right? That's where it really shines. But yeah, I guess kind of taking the questions to, are there any situations where like performance can be suboptimal and things can get worse maybe?
Yes. So the first issue is that you have to have like these filters with tend to change, right? Or on the same table. If your workload is like, let's say, just does joins, then Parachute is not for that, right? You need like this predicates that filters the table. So that's a very important aspect. The second point, I think, like the limitation is that you have to build these parachute columns ahead of time, right? And yeah, so future work is like to build them on the fly, but maybe that's your next point, like how to extend like Parachute to be really practical.
You've beat me to it there, Mihail. So the question would be like, where do we go next with Parachute, and how do you sort of overcome some of these existing sort of limitations? So yeah, how do we do it? What's the secret?
Yeah, so the second issue was that like you have to build these Parachute columns ahead of time. The idea is to build them on the fly. Say you see the queries of your workload, right? The queries run, and you see which filters tend to repeat in terms of the changing values. In that case, you simply drop a parachute on your table. Right? It's like this nice visualization. You just drop this parachute column or on a table, right? So that's a future work. Maybe the second is like to instance optimize the parachute columns. Say you tend to filter on years that, right, on more recent years. So maybe it's possible to optimize the histogram to have like wider buckets for the more recent years, right? So that's one point. And then another point is like to instance optimize like the string fingerprints. And we also have now like this paper on at IDB at VLDB, and we showed that you can basically instance optimize your like scans by up to 1.4 on DuckDB also. So that's pretty cool.
Yeah, very cool. Yeah. So my next question that comes up, we've spoken about how good Parachute is, even in its current form as well, without all these cool futuristic directions. And for the listeners, for the users of DuckDB, is this in the product, or is this can they get this through an extension? How can they basically access all this goodness you've made at the moment, Mihail?
Yeah, so Parachute is now open source, right? So it's like a very lightweight open framework with some scripts to run. And then you just have to build your parachute columns for your tables, and you are good to run, right? So it's as simple as it gets.
Cool. Well, we'll link that in the bio and stuff, so any interested listeners can go and give it a go. But cool. So whilst we're talking about DuckDB and sort of the experience of it and how users might use it, let's dig some more, pull the thread some more on what your personal experience was like building on top of DB. We spoke earlier about how long it took, but what was that experience actually like? Was it an enjoyable experience? And what would your advice be to other people that might want to consider doing something similar as well?
Yeah, so DuckDB is pretty cool, right? There is like this open source system which is there. It's fast, right? And the code base is also like very, very clean. Like I remember, I also changed the optimizer to use the parachute stats, right? And it was like pretty easy to extend. Yeah, so I mean, DuckDB is like really nice, has a nice user experience, right? So for Andy, like he did like this semi-join filtering and DuckDB. I think for him was like also like really cool since this push down was already in DuckDB 1.1, I think. So it was like really cool to extend and to see the gains.
Yeah, that's really nice. Have you had any feedback? You mentioned that it's open source, but have you had any feedback from users of Parachute yet?
Yeah, so Parachute is still like young, like VLDB is still next month, right?
True, yeah, it's not out there right yet, so it's still sort of in stealth mode a little bit, maybe.
Yes.
So yeah.
So one feedback I got was that like you have to build these parachute columns, right? But to specify the bit width of your columns, like that's not so user friendly. So one point to extend that's was a feedback was to set a space budget, right? Let's say you want to fix 10% for your parachute columns only. So 10% from the file size, and then in the background, Parachute should optimize the Parachute columns to account for this 10%. So that's one feedback. I will try to implement that since that's cool, right? So you could just like import Parachute, then Parachute set limit 10%, done. That would be like a very cool feature.
Yeah, for sure. I mean, like usability is such an important feature for any system, anything, right? So if you can reduce friction there, then it's going to help in the long run, right? Because for sure. I mean, how many times have we downloaded some piece of software, whatever it is, tried to get it working, it doesn't work after 5 minutes, we're like, God, no, I'm done with this, and never trying it again, right? So plus one on that would be a really nice enhancement. Yeah, longer term, do you think I was like to kind of ask this question, like, do you think the work you have had has had any influence on the core product at DuckDB and how that and like have you had any discussions with the core team and about how like they're like, okay, we might actually make this part of just the product full stop?
Yes, we actually had a discussion with them since they also wanted to implement semi-join filtering, right, with filters. That's a cool idea. And we had some feedback from them, right? That's pretty cool. The main issue was that, not issue, that meanwhile there is this robust predicate transfer. They have like, it's like an instance optimal algorithm. And that also is like semi-join filtering, right? But this modifies like the be pretty drastically. So there is now a discussion: should one just implement a semi-join filtering like this Bloom filter pushdown, or modify DuckDB so dramatically to account for a robust predicate transfer. So I think DuckDB maybe in the next versions will have some, let's say, heavyweight semi-genuine filtering, either from our team or from robust predicate transfer. Let's see. It's yeah.
It's an ongoing discussion, shall we say?
Yes.
But yeah, it's a discussion that's happening. So yeah, changes are on the horizon. But yeah, who knows what they will be? Yeah, okay, that's really cool. That's interesting to know for sure. Yeah, so my next question is like a kind of more of like a reflective question on your work on Parachute and on DuckDB, and across that journey, have there been any sort of what's been the most sort of interesting lesson then, shall we say? Let's phrase the question this way: what's been that's maybe caught you off guard or surprised you whilst working on this topic or with DuckDB as a system?
As a system, good question. Let me think. So surprise maybe, yeah. So surprise was that the optimizer is pretty good, like really good. There are some points where one could improve, of course, but I think this is a huge surprise. And of course, another surprise is like this very feature-rich implementation, right? They have like all these nice features you can just use. So this was for me a lesson that if you want to build a system that is used by anyone, right? Should be easy. I should have many features, and I think I learned a lot from their passion to build this system.
Yeah, that's a nice learning for sure. My next question is there's three areas three ways I want to go with this, and the first thing is like kind of we're in recommendation territory now. So the first is like, what is your favorite thing about DuckDB, be it a plugin, an extension, or feature? What's your like? I just absolutely love this. Maybe it's the optimizer. I don't know. What's your favorite thing?
Yeah, so that's the UDF extension, right? You can just put for me like it's magic, right? Why? Because if you think this way, I also built in DuckDB predicates from large language models, right? Like select table where I don't know, movie school, right? So it's possible, with this UDF extension, to apply any function, right? Also from ChatGPT and so on, right? And for me, that was a really cool surprise. And
nice. Yeah. Kind of going off then, what's the one thing you would love to see in DuckDB? We've got a complete wish list. We've got a genie. We can just rub it and we can get loads of wishes. Like, what is it? What do we want in there?
So a first point would be, and I think they already built it, to specify queries in natural language.
Yeah.
That's something VS Code also does not support. There is this Copilot, right? And you could in principle run in terminal just some commands, and that's you still have to ask in Copilot to write it for you and then run. For DuckDB would be natural language. I think they've fine-tuned a model for that, if I recall correctly. And the second one is to have a very cool semi-genuine filtering algorithm, right? That would speed up, pretty drastically the runtimes.
Nice. That's really cool. Well, we've arrived now at the time for the last word on the podcast. So, yeah, what's the main thing you want the listener to take away from the podcast chat today?
Yeah. So, with the Parachute, I learned a very important lesson. If you want to build something, just put Netflix, YouTube off, right? And then just focus on that. The main, the key idea is if you want to build something, there is this quote from Walt Disney. He said, "If you see the thing in front of you, you see what you want to build, then you should build it. If not, stop."
Okay.
And when I when we started with Parachute, I could saw the end product, right? So I could see where the things will go.
Nice.
And this motivated me. So as a recommendation, right? If you have like this motivation, just put all phones, Netflix to blow off, and then just do it. Because time is the only currency we have in this life, right? So you don't want to spend on YouTube, Netflix, and to waste your time, right? On nothing.
No, that's a lovely message to end on, Mihail. Yeah, I really like it. Yeah, if you got it in your mind and you can see it, just go make it a reality.
Yeah.
And yeah, don't waste your mind. Don't waste your precious brain cycles doom scrolling
exactly.
and watching trash on Netflix. But yeah, that's a great message to end on. Yeah. Sorry, go ahead.
That's the issue I see nowadays, right? People just watch series. They waste their time, and for what?
Yeah, it's very true. Yeah, it's so easy to fall into that trap of just wasting time. And like you say, time's the only currency we've got. So
yeah,
great. Let's call it a wrap there. Then I mean, for the listener, all the things we mentioned today, we'll link those in the show notes. And yes, do go play with Parachute and give Mihail some feedback on what you find and all of and how we can improve usability and how much you loved it. But yeah, this has been a lovely chat. Thank you very much.
Thanks. Thanks, Jack.